Hello everyone. In our previous lectures, we discussed about jets hitting either a flat plate or a curved plate. But when we discussed curved plates, one thing we have to notice is that the jet always strikes on the concave side of the surface of the plate. But we did not address what would happen if the plate was kept like this and the jet was hitting on the convex side. That means on this side of the plate. We'll try to address that in this lecture. So when theta is less than 90 degree, there can be two different cases. One is if the plate is having a pointed end, a pointy end. So in this case, if we consider a jet striking this plate right at this pointy end, then you can imagine what will happen quite easily, because the water will be spread along the surface like this in all the directions, and whatever was the inclination of this surface with the axis of the jet, suppose theta, and based on that we can find out F equals rho a v square 1 minus cos theta. The formula is not changed from what we have discussed or derived in the previous lectures, so it's the same formula. Only thing is that in a curved plate which was hit by if the curved plate was like this, and in that case water was displaced or deflected by an angle which was greater than 90 degree. In this case, this angle is less than 90 degree. But the problem is, what will happen if the plate is not pointy? It means it has a blunt end. So such kind of a plate will be like this. So in this plate, what will happen is that after hitting this surface, suppose at this point, if you observe carefully, there may be two cases. In one case, it may happen that water will simply get deflected like this. That means water will separate from the surface of the plate, and it will be almost like hitting a flat plate, and the curvature doesn't matter. But there can be another case where the water is hitting on the curved surface on the concave side, and after hitting, water is not deflected in this direction, but water gets deflected like this. That means the water doesn't separate away from the surface and it moves along the surface. Now, why would this happen? So there can be two cases. If the velocity is not very high, in that case, this case will happen where water will stick to the surface, and that's the only reason for this is the surface tension, or rather than calling it surface tension, we should call it the adhesive force, or the or the attractive force between the surface material of the plate and the fluid, suppose water or some other fluid. So if that surface attraction is strong enough, then the kinetic energy or the velocity is not sufficient to separate this liquid from the surface. Now what happens is that if we have a surface like this, then after the jet hits this surface, it gets deflected in this direction. That means at this point it has a very small component in this direction which is away from the surface, and if the curvature was very sharp, then that component will be even stronger. Now what happens is, when this component is there, very small component away from the surface, then if the surface attraction between the solid surface and the liquid is strong enough, and if it is stronger than this component, then the water will not be able to move away, but it will be sticking to the surface. But if the velocity is very high, then this component will also be proportionately higher, and in that case at some point this will be able to overcome or escape this attraction force between the surface and the liquid, and therefore it will be able to move away from the surface, and this case will happen. Now to actually have this, you'll have to use a very high velocity jet, and generally in your household examples it will be difficult to find, but you can just experiment on this just by going under a water outlet, a tap, and try to you can try to hit the surface of your hand or feet, which will be having, suppose if your hand is like this, it's a very bad drawing of a hand, and on your knuckles you try to hit your knuckle with a water jet from the tap, suppose. So you'll see that water will not be deflected like this, and it will be moving along the surface. But if you can somehow increase the velocity of water, at some point water will spread away from your knuckle or any curved surface. So it will be deflected away from the surface if the velocity is very high, because the deflected velocity will be sufficient enough to escape the surface attraction. And if the velocity is not that high, then it will not be able to escape, and it will flow along the surface like this. Otherwise it can move away from the surface, and therefore the force in this case, in case of a pointy end, it was easier. The force was simply given by this formula. But in these cases, if the surface is curved, then it will depend on how the water is deflected. If it is deflected like this, then the force will be less. If it is deflected like this, in this case the force will be more, almost equal to what we had with a flat plate. But in this case it will be somewhat comparable to this case, and you will have to find out what these angles are. Suppose if this is the direction, the final direction, and what is this angle that will bend. Otherwise in this case the angle is almost 90 degree. This part will not be covered in your included in your exam syllabus, but this is something interesting that I thought should be mentioned. So thank you.